right, let's do this. I'm going to go pretty quick here, guys, because hopefully you're just checking answers. So I plug in my 2, and I'm getting 1. Here I plug in my 2, and I'm getting 0 over 0. Now that's undeterminable. So when I look at this, I'm going to try factoring or anything else I can think. That definitely looks like factoring will help. So once I factor, yay, those cancel. And now I can just try plugging in the 2 again. So 1 over 2 plus 2 is 1/4. Okay, over here I'm going to try plugging in first. So 1 goes in there, and that's a 3. 1 goes there, and that's a -8. Done. Gotta love those when they work. Try plugging in a 1, and I'm going to get 1 plus 6 plus 5. Okay, so 1 plus 6 plus 5 is what? 11? No, 12, duh. And then I'm going to get a 0 on the bottom. Okay, so when that happens, that limit does not exist, everybody. It really doesn't. It does not exist. Okay? Down here. Oh, and by the way, it's probably a vertical asymptote if you're wondering. And if you want to look at the graph, I bet there'll be a vertical asymptote at 1 whenever you look at it. Okay? So it does not exist. Okay, number 5. So it's trig, but don't be scared. Take the pi, plug it in, and the sign at pi means the y value at pi. And if I think of my circle, the answer would be 0. Okay? Over here, I'm going to try plugging in a 1, and I can already tell that's going to give me 0 over 0. So this is like that one I showed you. There's no factoring, but since there's all these crazy fractions, I'm going to try to get a common denominator first and figure that out. So that becomes a 2, and then an x plus 1 here, and then it's all over x minus 1. So now when I simplify this, it's going to be 2 minus x minus 1. So 2 minus x minus 1, that's a minus x plus 1. Yeah. And then minus x minus 1. Yeah, I did that right. And then it's all over this, which is 2 x plus 1, x minus 1. Now, you might have stopped here, because you remember these denominators go together. You might have stopped here and thought, well, that didn't help me. Okay, that did help you. I don't know if you see it, but right here and right here, these are the same thing, except one of them's been multiplied by -1, right? I mean, look at this. If I multiply this by -1, it will equal that. So on that belief, if you take a -1 out of this, it is equal to the thing in the bottom. So if you just rewrite this as this, then we can cancel out those two. And I'm just left with a -1 over 2 times, now I'll plug my 1 in, 1 plus 1. Kind of a nice little trick that a lot of people miss, but hopefully, you know, if you got that, give yourself a high five. That's pretty tricky. Number 7, I'm going to try to plug in a -3. Well, it's definitely a 0 on the bottom, and then on the top, it's also a 0. Okay, so undeterminable, which means do something. Try to figure it out. So I'm going to do the conjugate trick that I showed you on the notes, which means I need to multiply top and bottom times 2 plus 1 minus x, or square root of 1 minus x. And when I do that, I'm going to FOIL the top, but I'm going to leave the denominator alone. So that's going to be 4 plus 1 of those minus those, so those are gone. So minus everything that's in the radical, all over x plus 3 times 2, blah, blah, blah. Alright, so hopefully, you know, if it took you more steps to get to that, that's fine, but we should be at the same step here. And then 4 minus 1 is 3, minus a -x is a plus x. So that is all the same thing as 3 plus x. Yay! Which when you look at the bottom, there's another x plus 3, so those can be canceled. There's a 1 on top, and then we'll plug in our x. So our x is a -3, which makes that a square. That makes that a 2. Man, there's a lot of 1/4 as the answer, but what can you do? Sometimes there's a lot of the same thing. All right, there we go. And number 8, try direct substitution. Oh, I already did. Haha. I think that was an x, and then I went ahead and plugged it in. Okay, so we're going to try plugging that in. So when we try to plug that in, okay, the cosine of pi over 2 is the x value at pi over 2, which is up here. The x value up there is 0, so it's 0 over pi. Okay, this is, a lot of people get wigged out. They're like, undeterminable or does not exist. No, it's 0 over a number, and if it's 0 over a number, it's always just 0. Okay, so there's our first 8. Now, what happens on 9, 10, and 11? Well, a lot can happen, and I'm going to show you one example for each. But remember, like, many things are possible. So you'll just need to show me yours, and I'll tell you if you did it right, either in tutorials, or you can email me if you're not coming to the tutorials, okay? Number 9, create a function that has a limit of 0 as x approaches 1. So what it's saying in notation, as x approaches 1 of some function, they want it to equal 0. Now, I probably should have specified I don't want a picture here, okay? This is equation week, not picture week. So you need to create an equation that does that. So I need the top to go to 0. So like my equation for f of x would have just been like, well, you don't even need a fraction. You could have just said like x minus 1. Done. Because if x minus 1 had been right here and we had plugged in that 1, the limit would be 0. So that would have been my example. Number 10, create a function that has a limit of 3 as x approaches negative 2. So we want the answer to be negative 3, okay? So I'm going to plug in, and maybe it could be, I don't know, it can't be 1 minus x, but maybe it's like, gosh, I'm having a hard time thinking about this. There's a lot of things you could do, guys. There really is a lot of things you could do. To get from negative 2 to negative 3, I need to subtract 1. So is it really the same thing as what's above? It is. Crazy. Okay, so I could have used the same function for both of those. That was purely coincidental and accidental. And whatever you did here, just check your work and make sure that if you plug in this one, you do in fact get that one. Oh wait, you know what I messed up? Someone's going to catch me on it. You know who you are. That was supposed to be a positive 3. Tee-hee. So I'm going to change that to 1 minus x. And then that would have worked. Sorry. My bad. I copied it wrong. Number 11. Create a piecewise function. Ooh. So 2 pieces. Has a limit of 2 from the left and a limit of 0 from the right as x approaches 4. So as we're approaching 4, so what that means here is if I need to come to 4 from the left, that would mean that x is less than 4, and then from the right, that would mean x is greater than 4 or greater than or equal to. Whee! So 4 is the magic number over here because that's the x that we need to be approaching to where we get 2 different answers. Now, this is my left, so this is approaching from the left, this is approaching from the right. So what did it say? From the left, we want the answer to be 2. So when I plug in that 4, I want the answer to be 2. Well, doesn't that work? 4 minus 2 is 2. So that would totally work. And from the right, it wants it to be 0. So how do I make it a 0? Well, how about x minus 4? I plug in that 4. 4 minus 4 is 0. These can be as complicated or easy as you want. You could have done quadratics, you could have done a fraction like a rational expression, you could have done trig if you're really sneaky. I mean, it doesn't matter. I went easy peasy. I went with the easiest thing I could think of, which is just linear. But do whatever you want. So, yeah, we'll play with more of those in tutoring if you're coming, and otherwise, see you next week.